Hey everybody, this is Mr. Longo getting ready to talk to you about parts of parabolas, which of course you know are quadratic equations, meaning y is equal to x squared. Now, there are all sorts of different types of quadratic equations we're going to be talking about. This video is just to discuss the important parts of a parabola. So there's a couple of things we're going to talk about first, and that's the vertex, whether or not that's a maximum or a minimum, and the axis of symmetry. A vertex is the point where the graph changes from decreasing to increasing, or if it was upside down, from increasing to decreasing. It's also known as like a turning point. So this right here is our vertex, and his coordinate is 4, -3. Okay, now in a parabola, there's going to be a maximum or a minimum. When we get to other polynomials, such as x cubes, x to the fourths, x to the fifths, we can have multiple maximums and multiple minimums. But in a parabola, you're only going to have one or the other. Now, since the vertex is at the bottom, the lowest point in this graph, that's going to be our minimum. So our minimum is also 4, -3. We do not have a maximum because it goes up forever and ever and ever. Now, an axis of symmetry is always going to go through your vertex. So the axis of symmetry here is a vertical line that splits the parabola in half, and the axis of symmetry is x equals 4, because you remember a vertical line is x equals the x coordinate. Now, how can we use the axis of symmetry? We can use the axis of symmetry to graph points. So, if we were to look at one of our points, which is 5, -2, that's 1 to the right of the axis of symmetry. Well, 1 to the left would be 3, -2. They're always going to be perfectly symmetrical. Okay, so 2 to the right, 2 to the right, 3 to the right, 3 to the left. It's all going to work out and be a symmetrical part of the parabola on the left side and the right side of the axis of symmetry. Okay? The next thing we're going to talk about is end behavior and increasing and decreasing intervals. End behavior is, what does the parabola do as it goes to the left or it goes to the right, also known as positive and negative infinity. So as x approaches -infinity, that means as this graph goes to the left, where is the function going? Where is f of x going? It is going down forever and ever and ever. So that means it's approaching -infinity. So negative infinity works for x's and y's. When it's an x value, it's going to the left. When it's a y value, it's going down. Now we also have to look at what happens when x is going to positive infinity, also known as what happens to the graph as x gets bigger or goes to the right. Well, the graph is still going down, so end behavior, it's still approaching -infinity. Okay? Now our increasing and decreasing intervals. When you are talking about intervals, you always have to think in terms of reading. We always read left to right, so we're going to read a graph left to right. So coming from the left, we see that the graph is increasing all the way until it gets to our maximum point. So it increases from -infinity. Here's your notation. When we're talking about interval notation, a parentheses means that -infinity is not included because you can't get to -infinity. And it stops increasing at -3. Okay, so that means this graph increases from -infinity to -3, and of course we're talking about our terms in x. After it gets to the maximum value, it decreases, so it's going to go down for the rest of the graph, all the way up to 250 million or whatever you want to say. So -3 is still that maximum height, but it's at x equals -3. That's where you're at your maximum. And then it will continue to positive infinity. It will continue to decline. or decrease. Okay, so that's our end behavior and increasing and decreasing intervals. The last important parts of a parabola are the intercepts. We have x-intercepts and we have y-intercepts. The x-intercepts is where it crosses the x-axis. So in this case, we have those 2 points. So we have a -5, 0, and we have a 1, 0. Now, whenever we're talking about intercepts, they are coordinates on a graph, so you want to use them in coordinate notation. Now, the interesting thing about x-intercepts is sometimes you don't have any, sometimes you only have one, and that really depends on which direction your parabola is opening and how many times it's going to touch the x-axis. So we can graph a parabola that opens up and have the vertex be above the x-axis, so you'll never have an x-intercept on this type of graph. So those can change. The y-intercept, we're going to have one y-intercept because it is a function, so it has to pass the vertical line test, and that's where it crosses the y-axis. So our y-intercept is 0, 3. Okay, so those are the important parts of parabolas that you will need to know. So what we're going to do is just give you the opportunity to try a couple of these on your own. So the first one, why don't you pause the video really quick and see if you can list all of the information for this one. As soon as you're ready, click play and we'll go through it together. Okay, so the first thing is the vertex. The vertex is, of course, this guy down here at the bottom. So our vertex is at 1, -9, which is also, again, our minimum. Because it's at the bottom, we have no maximum. Okay, so that's that point right there. Our axis of symmetry is always going to pass through the vertex. So our axis of symmetry is a vertical line at x equals 1. It's always the x-coordinate of the vertex. Our x-intercepts, we have 2 of them. We have one here at -2 and one at 4, but of course we're going to write them as coordinates. So -2, 0 and 4, 0. We have a y-intercept. Our y-intercept is right here where it crosses the y-axis at 0, -8. Okay, so those are all of our important points. Now we'll just discuss the direction of which everything is going. So as x approaches -infinity, this is our end behavior. So as x goes to the left, our graph is going up. So the function is going to positive infinity. As the graph is going to the right, or as x approaches positive infinity, the graph is still going up. So it is also approaching positive infinity. Now, little sneak peek, if we have any type of quadratic, x squared or x to the 4th, any even exponent, the end behavior is always going to go in the same direction. Okay, little spoiler alert. Increasing intervals. This graph decreases. Remember, we read left to right, so it decreases from the left, and as it goes to the right after our vertex, it increases. So our increasing interval is from where x equals 1 on to positive infinity. It decreases coming from the left, which is negative infinity, and once we get to the bottom at x equals 1. Okay? So that is another example of listing all the information about a parabola by looking at the graph. So one last try. If you had a few questions about that last one, why don't you pause the video one more time and see if you can handle the rest. So the vertex you should have had is at -5, -1. There is a maximum of -5, -1 because you can see that the vertex is at the top of the parabola. That means you have no minimum. Again, your axis of symmetry is the vertical line that passes through your vertex. So it's x equals -5. This is an example where you have no x-intercepts because the vertex is below the x-axis and it's opening down. We have one y-intercept at 0, -4. As far as end behavior goes, again, as we spoke in the last question, it's going to fall down towards -infinity in both directions. So your end behavior for both was -infinity. That's where f of x is approaching. Our increasing interval, it's going up from -infinity. So it's -infinity, and it stops once we get to an x value of a -5. And then once we get to that -5, it starts to decrease, and it will continue to decrease as x gets larger and larger into positive infinity. All right, that is it for this video on important parts of parabolas. This is Longo, and I'm out. See you, bye.